Hi, so this is the third video for continuity of a function. We are doing chapter number 5 from NCERT of class 12th. In the previous video, we have solved until question number 7 of exercise 5.1. In this video, we will look at the next set of questions. All right. Okay, so the question number 8 here is fx is equal to mod x upon x when x is not equal to 0, and fx is equal to 0 if x is equal to 0, and we have to check the continuity of this function. So as you can see here, the function is changing its behavior at the point x is equal to 0, right? At x equal to 0, the value of function is how much? It is 0. And for x not equal to 0, for example, if x is 0.5 or if x is minus 0.7 or if x is 20, whatever the value of x be, apart from x equal to 0, the function is going to be defined by mod x upon x. Okay, so we can see that the function is changing its behavior at the point x is equal to 0. So this is where we are doubtful whether or not this function is continuous here or not. Okay, so as you know, in the previous video we discussed that in any question where mod x is given to us, we have to first define mod x separately. Okay, so what is the definition of mod x? Mod x is equal to x if x is positive. We can take equal to 0 also in this one, and mod x is equal to minus x if x is negative, that is if x is less than 0. This is the definition of modulus function that you must remember. Definition of modulus function. Okay, mod x is equal to x when x is positive, and mod x is equal to minus x when x is negative. Alright, so based on this, we can partition this function into categories. Alright, so for question number 8, we can write fx is equal to, so we can substitute mod x is equal to x, so it will be x upon x if x is greater than 0, and it will be minus x upon x, so we are simply substituting the value of mod x here if x is negative, and it is 0 if x is equal to 0. Now you must have noticed that in this question it is already defined that the function is equal to 0 if x is equal to 0. So we did not consider the equal to sign that we have in here. So we only took x is positive, x upon x, x is negative, minus x upon x, and if x equal to 0, we will take what is given to us in the question. Alright, so this is what we get. Now what is x upon x? Is equal to 1. So we can say this is equal to 1 if x is positive. The function is equal to minus 1 if x is negative, and the function's value is 0 if x is equal to 0. As you can clearly see that this minus 1 is actually the left hand limit value, so it is minus 1, right? And this 1 is actually the right hand limit of this function, and this 0 is the value of the function when x is equal to 0. So clearly fx is not continuous at x equal to 0, but we will write it formally. So we'll write at x is equal to 0, at x is equal to 0, the value of the function is equal to 0. It is given to us fx is equal to 0 when x is equal to 0. Now we'll calculate the limit of the function at x tending to 0. X tending to 0 means when x is approaching 0 either from left side or from right hand side. Now because we can see that if x is positive, then the value of function is 1, and if x is negative, the value of function is minus 1. So we have two cases here. So we'll have to write the left hand limit and the right hand limit separately. So we'll write LHL is equal to limit fx x tends to 0 minus. 0 minus means we are approaching 0 from the left hand side, from the left neighborhood of 0, which means the value of x is going to be slightly less than 0. When the value of x is less than 0, the value of the function is minus 1. So we'll write here limit of minus 1 when x is approaching 0 from the left hand side. Now there is no x term present over here, so we don't have an option to put direct substitution here, so the value will just be minus 1. Alright, now we'll write down the right hand limit. So the right hand limit will be equal to limit fx x tends to 0 plus, this will be equal to limit x tends to 0 plus, and x tends to 0 plus means slightly more than 0. The value of x is slightly more than 0. So the value of function is 1 in this case, and this will be equal to 1. So you can see that LHL is not equal to RHL, and therefore limit does not exist. Limit fx x tends to 0 does not exist, and if the limit itself does not exist, the function cannot be continuous. So we'll write therefore fx is not continuous at which point? At x is equal to 0. Fx is not continuous at x equal to 0. So this is how we solved question number 8. Question number 9 is based on the similar idea. Let us look at this one also. So question number 9. So question number 9 is saying fx is equal to x upon mod x. Fx is equal to x upon mod x if x is negative, and the value of fx is given as -1 when x is positive. When x is positive and equal to 0 also. When x is equal to 0, then fx is equal to -1. So this is how it has been defined. Now we know that if x is negative, then what is mod x? Mod x is equal to minus x, right? So we'll write x upon minus x, which is equal to -1 when x is negative. And here we don't have to modify anything because it is very simple. All right, so fx is equal to -1 when x is negative, and fx is equal to -1 as well when x is 0 or more than 0. So clearly the function is continuous because its value is not changing. It is always equal to -1. Okay, but we can write the formal wording at x is equal to 0. Why at x equal to 0? Because the function is partitioned that way, right? So if we look at x equal to 0, what is the value of the function at x equal to 0? It is equal to -1. We got this from this one, right? Now we'll write the limit of the function. We'll write the limit of the function when x is tending to 0. When x is approaching 0 from the left hand side, so we are evaluating left hand limit over here. When x is slightly less than 0, the value of function is -1. So we'll just write -1 here, x tending to 0 minus. So this will be -1. And when we calculate the right hand limit, it will be limit of the function when x is tending to 0 plus. 0 plus means slightly more than 0. For slightly more than 0, the value of the function is again -1 from this one, right? So we can see this is again -1. So as these three are equal, the function is continuous at x equal to 0. So you can write LHL is equal to RHL is equal to F0. Therefore fx is continuous throughout its domain. We always check the continuity of a function in its domain only. Fx is continuous throughout its domain. I hope this is understood. So we have completed question number 8 and 9. Now let's move on to question number 10. So what is question number 10 asking us to do? To check the continuity at x is equal to 1. Why at x equal to 1? Because this is the point where the function's behavior is going to change, right? So now let us solve question number 10. Let us directly write the value of f1 first. F1. Okay, before this let me write at x is equal to 1 to tell the examiner that we are checking the continuity of this function at x equal to 1. So at x equal to 1, what will be the value of this function? So we'll use the first one. Why first one? Because it is applicable for x is greater than or equal to 1. This is the one where we have equal to sign. So if we put x equal to 1 in here, we'll write 1 plus 1. So this will be equal to 2. Okay. Now we'll calculate the limit of the function when x is tending to 1 minus, and then we'll calculate the limit of the function when x is tending to 1 plus. I hope by now you have understood that this is actually the left hand limit and this is actually the right hand limit. Now for left hand limit, we'll have to write the value of fx which corresponds to the value of x being less than 1, which is x square plus 1. Now we'll solve this by direct substitution. So just put the value of x as 1 over here. You'll get 1 square plus 1 is equal to 2. So far so good. Now let us calculate the right hand limit value. So this will be limit x tends to 1 plus. So for x greater than 1, the first one is applicable. Now we'll solve it by direct substitution. So you can see that all these are equal to 2. Therefore LHL is equal to RHL is equal to F1, and therefore fx is continuous at which point? At x is equal to 1. Correct. So this is our final concluding statement. All right, now what is question number 11? Question number 11 is based on the same idea. Question number 11 is telling us, here you can look at this question. So at which point do we check the continuity? At x is equal to 2. Okay, at x equal to 2. Why at x equal to 2? Because the function is changing its behavior at x equal to 2. It is partitioned based on x equal to 2 value. All right, now let us first calculate f2. What is f2 going to be? Do we use the first one or do we use the second one? We will use the first one. Why? Because this is for x is less than or equal to 2. So 2 cube minus 3. So this is 8 minus 3, which is equal to 5. Let us calculate the left hand limit and the right hand limit. So left hand limit will be for x tending to 2 minus, and right hand limit will be for x tending to 2 plus. All right, so now when x is less than 2, when x is slightly less than 2, we'll use the first definition of function. So we'll use x cube minus 3 here, and this will be x tends to 2 minus. Just substitute x is equal to 2 here, so you will get the same thing that we got previously. Now when x is greater than 2, the second definition becomes applicable. So this will be limit x square plus 1, x tends to 2 plus. Now substitute 2 over here, so this will be 2 square plus 1, which is 4 plus 1, which is 5. So you can see that LHL is equal to RHL, which is equal to f2. Therefore function is continuous or discontinuous? Function is continuous. In every question you have to solve, you have to find the value of the function at that value of x, and then you have to find the limit of the function when x is approaching that particular value of x. That is it. So question number 11 is done. Now let us look at question number 12. Question number 12 is also based on similar lines. Where do we check the continuity of this function at x is equal to 1? Because the function is changing its behavior at x equal to 1. All right, so let us solve question number 12 now. So in question number 12, we'll write at x is equal to 1. You can look at the question here, at x equal to 1. So at x equal to 1, what is going to be the value of the function? We'll use the first one. Why the first one? Because this is applicable when x is less than or equal to 1. So this is going to be 1 to the power 10 minus 1. Now 1 raised to any power is always 1. So 1 minus 1 is equal to 0. Okay, so this becomes 0. All right, now let us calculate the left hand limit. The left hand limit will be limit of the function fx when x is tending to 1 minus. For 1 minus, we'll use this one, the first one, x to the power 10 minus 1. So x tends to 1 minus, x to the power 10 minus 1. So we'll get the exactly same answer which we got previously. This is 0. Now we'll calculate the right hand limit. Right hand limit will be limit fx, x tends to 1 plus. So this will be equal to limit x to the power 2, x tends to 1 plus. So we'll substitute x equal to 1 over here. So this is 1 square is equal to 1. We can see that LHL is not equal to RHL. Therefore, limit of the function fx does not exist when x is tending to 1. It does not exist. And if the limit does not exist, the function cannot be continuous at that point. So we'll write fx is discontinuous. Fx is discontinuous at x is equal to 1. So this is the answer of this question. Fx is discontinuous, or you can write fx is not continuous at x is equal to 1. Okay, that's about this question. All right, now let us look at question number 13. Question number 13 is partitioned at x is equal to 1. The function is changing its behavior at x is equal to 1, right? So the question is asking us whether it is continuous function or discontinuous function. So it is very simple. So question number 13 we can solve. We can write at x is equal to 1. At x equal to 1, the value of the function will be, we'll use x plus 5 because it is applicable when x is less than or equal to 1. So 1 plus 5 is equal to 6. Now let us write the left hand limit. Limit fx. Now what do we write here? If you have been taking notes, if you are writing everything that I am telling here, then you must know what to write here. So what do we write? X tends to 1 minus. For 1 minus means x is slightly less than 1. So when x is slightly less than 1, the first one becomes applicable. So we'll use x plus 5, and by direct substitution we'll get LHL is equal to 6. Now RHL is equal to limit fx x tends to 1 plus. So when x is slightly more than 1, we will use the second definition, which is x minus 5, right? So when we use x minus 5, just a moment, when we use x minus 5 here and we do direct substitution, we write 1 minus 5, which is equal to minus 4. So as you can see there, that LHL is not equal to RHL. Therefore, does the limit exist? No, the limit does not exist. So this is the situation where limit fx x tending to 1 does not exist, and if the limit does not exist, the function will not be continuous. So we'll write fx is discontinuous. At which point is it discontinuous? At x is equal to 1. Correct. So fx is discontinuous at x equal to 1. If you are able to understand what we are explaining here, then that is great. अगर आपको समझ में नहीं आ रहा है तो प्लीज कमेंट कीजिए अपने डाउट्स को. All right, so that is question number 13. Now let us look at question number 14. Most of these questions are on similar lines. So if we solve question number 14, you can look at it over here. So at which all points can you see that the function is changing its behavior? So as you can see here, this is applicable when x lies between 0 and 1, and this is applicable when x lies between 1 and 3. So 1 is appearing in both of these inequalities. So we must check whether the function is continuous at x equal to 1. Alright. Similarly, here we can see 3 and here we can see 3. So we should also check whether the function is continuous at x equal to 3 or not. Alright. So in such questions, always find out whether or not the function is continuous at that value of x which is appearing in two inequalities. Alright. So now we'll solve it. First of all, we'll check the value of function at x equal to 1. So at x equal to 1, f1, so we'll use x less than equal to 1 case. So we can see the value of fx is equal to 3 here. Now we will write down the value of left hand limit. The left hand limit is going to be limit fx x tends to 1 minus. For 1 minus, it is anyways equal to 3 only. So we'll replace fx with 3. So this becomes equal to 3. Now what is the right hand limit going to be? Limit fx x tends to 1 plus. When x is more than 1, we can see that the function becomes equal to 4, right? So we'll put fx is equal to 4 here. So we'll get 4 here. Now LHL is not equal to RHL, which means that limit does not exist. Limit fx x tends to 1 does not exist. And if the limit does not exist, it simply means that the function is discontinuous. The function is discontinuous at which point? At x is equal to 1. The function is discontinuous at x equal to 1. So these are the steps that you need to perform for every value of x where you want to check the continuity of the function. Now let us check the continuity of this function at x equal to 3. At x equal to 3, what will be the value of function? So we can see for x greater than or equal to 3, the function value is 5. So it is 5, right? Now let us calculate the left hand limit. Left hand limit will be for the value of x which is slightly less than 3. Value of x which is slightly less than 3. So we can see here that when x is less than 3, the function's value is equal to 4. Okay. So this means that the left hand limit is equal to 4. What about the right hand limit? Right hand limit means the value of x is going to be slightly greater than 3. When x is greater than 3, the value of this function is equal to 5. Okay. So this comes out to be equal to 5. LHL is not equal to RHL, which means that limit of the function fx when x is tending to 3, does it exist? No, it does not exist, because left hand limit is not equal to the right hand limit, and therefore fx is, what do we write? Fx is discontinuous. At which point is it discontinuous? At x is equal to 3. I really hope that you are able to follow what is being explained here. If you still have any doubts, please comment down in the video and I'll make sure I'll respond to your doubts and I'll clear your doubts. If you like this video, please hit the like button and please subscribe to the channel for more videos. Alright, so thanks for watching. Next we'll continue the next one. Thank you. Bye bye.